Hello students. So today's question is, find the mass capital M of the hanging block in the figure below, which will prevent the smaller block from slipping over the triangular block. All the surfaces are frictionless and the strings and pulleys are light. So this question could look a little complicated in the first go, but if you just analyze things, because condition has been simplified, if we want small m not to slip over m dash, the wedge, the triangular wedge here, triangular block here, that basically means that we can consider small m and m dash as one single system which is moving together. Yes, so this simplifies the system, the whole overall system for us very much, and the question as such becomes very simple. So if you look at this figure, and if we assume that for a value of capital M, the system is such that M is moving down with an acceleration A under the effect of this tension T and its own weight, the weight of the mass capital M. The same tension will act on the triangular block also, because it is given that the string is massless, so the tension throughout the length of the string will be the same. And it is this tension force which will make these two blocks M dash and M accelerate towards right together with a common acceleration A. Both M and M dash will move, and we can consider them as a single system if we write the Newton's second law for them. So all we need to do here is we first find out a relationship for the Newton's second law for both the systems that are moving here, that is the common system of small m and m dash as well as the block capital M. Once we get that, then we will separately work for small block m to see for what value of A will it move along with the triangular block m dash. We will find out a condition for that, and then we will combine the two things together to get our answer. So see, the steps here are quite simple. We first talk about the two blocks m dash and m moving together. So for them, the only force that is making them move towards right is the force of tension T, because of which m dash and m are having an acceleration A, let us say. We understand that the same acceleration then will be there with the block capital M also. So for block capital M, again we can write a similar equation, force equation, which in case of capital M will be the net downward force, which is capital Mg minus T, is equal to the mass of the block times its acceleration. We can solve these two equations to get a relationship between capital M in terms of A. This is the relation that we will get after solving the equations. Maybe we can add the two equations so that tension goes away and then you solve it further. Now we can get the value of capital M, which they have asked us in the question, if we could just get the value of A, the acceleration with which the system should move, and we can substitute it here, for which now we will consider the small block m separately. We will draw the free body diagram of small m and we will see how the things are connected here. So this is the block small m, and if you look at it, there are only two forces acting on it, its weight and the normal reaction from the triangular block. There is no friction as all the surfaces are smooth. And for this block, because it has not to slip over m dash, that means it will have same acceleration as that of m dash. That means under the effect of these forces, this is the acceleration of m, and now we can write the Newton's second law along two perpendicular directions, one of which we can take along horizontal and the other along vertical. Along the vertical, since the block is not moving, its net force must be 0. So along the vertical, this will be the equation for balancing the forces. N cos theta c will be the component of n in the upward direction, which will balance mg, as well as along the horizontal, the force component will be n sin theta. This component will be n sin theta, which will create an acceleration A in the block, so that you have net force is equal to mass into acceleration as the second equation for block small m. Now you can simplify these two equations once again, dividing the lower equation by the upper equation. We get this expression in tan theta is equal to A by G, from where you get the value of A in terms of G and theta. And it is this value of A now that you can substitute back in the equation 3 to get the final answer for capital M. So see, I have done the calculations here. When you substitute the value of A in equation number 3, this is the answer that you will get for m. So quite simple a question. We just have to get a relation between a and m, and then we have to solve for the value of a using the smaller block taken separately. Otherwise, you can consider this whole system together because it has a common acceleration. All the blocks are moving with one single acceleration here. Thank you.